Good day, my dear grade 8 students. Our lesson for week 7 in Mathematics 8 is about congruence for right triangles. This is Mrs. Reina S. Corpus, Master Teacher 2 of Urdaneta City National High School. Just a little trivia. Did you know that the origins of right triangle in geometry can be traced back to 3000 BC in ancient Egypt? The Egyptians used special right triangles to survey land by measuring out 3, 4, 5 right triangles to make right angles. There are so many ways where we can see right triangles in real life situation. But first, for the most essential learning competencies for this week, we have state and illustrate congruence postulates for right triangles. Number 2, apply the postulates and theorem on triangle congruence to prove statements on congruence. Now, going back to right triangles in real life situations, we could find it on the stairs in our house or on the roof, and especially used in building houses and bridges. Now, do you think there is a relation between the bridge or the picture in your ambition in life? Sometimes we are full of ambitions, but before we achieve it, we should cross the bridge first and face the challenges that we will come on our way in order to become successful in life. So you see, there is a relation between the triangles that you can see on the bridge to your ambition in life. Now, let us have a review on the parts of a right triangle. We have here line segment AB and line segment BC, which are the legs, while line segment AC, the longest side of the right triangle, is called the hypotenuse. It is the opposite of the right angle here. So the two parts of right triangle are leg and hypotenuse. Now, there are four congruents for right triangles. The first one is the LL congruence theorem. If the two legs of one triangle are congruent to the two legs of another triangle, then the two triangles are congruent. Now, in our example here, we have two triangles ABC and triangle DEF with angle B and angle E as right angles. These are congruent angles because all right angles are congruent. Line segment AB, which is a leg, is congruent to line segment DE, which is another leg. Line segment BC is also congruent to line segment EF, which is also a leg. Therefore, triangle ABC is congruent to triangle DEF by LL congruence. Can you still recall which congruence postulate is similar to this? Very good. This is similar with the side angle side or the SAS congruence. We move on to number 2 congruence theorem. We have the LA congruence. L stands for leg and A stands for angle. If a leg and an acute angle of one right triangle are congruent to a leg and an acute angle of another triangle, then the two triangles are congruent. We have here two examples for you to understand. We have triangle GHI and triangle JKL, where the right angles are at angle H and angle K. Line segment HI is congruent to line segment KL. What part of the right triangle is this? Very good. It is the leg. And Angle I is also congruent to angle L. What part of the triangle is this? It is an angle. So therefore, triangle GHI is congruent to triangle JKL by LA congruence. We move on to our second example here. Triangle NOM and triangle POM. The right angle is found here at angle O. Line segment OM is congruent to line segment OM by reflexive property. And by the given, angle ONM is congruent to angle OMP. Therefore, triangle NMO is congruent to triangle PMO by LA congruence. So, which state or congruence postulate is the same with this LA congruence? Okay, it is the same with ASA or ASA congruence. Okay, number 3. We have the HA or sometimes called high A congruence. High stands for hypotenuse and A the angle. If the hypotenuse and an acute angle of one right triangle are congruent to the hypotenuse and an acute angle of another triangle, then the two triangles are congruent. There are two examples here also. So we have angle R congruent to angle U. QS is congruent to line segment TV, which is the hypotenuse. Angle Q is congruent to angle T. Therefore, triangle QRS is congruent to triangle TUV by high A congruence. Another example would be like this. WY is congruent to ZC, the hypotenuse. Angle X and angle A are both right. Angle Y is congruent to angle C. So therefore, triangle WXY is congruent to triangle ZAC by HA or high A congruence. Again, this is the same or similar with the SAA or AAS congruence. Angle, angle, side or side, angle, angle. And for the last congruence theorem, we have the HL or the high L congruence. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then the two triangles are congruent. So in the figure, angle O and angle A are right angles. JY is congruent to SD. JY and SD are the hypotenuse of both triangles. OY is congruent to AD. OY and AD are the legs. Therefore, triangle joy is congruent to triangle sad by HL or high L congruence. I hope you could follow. Now, for our first activity, the title is Which is the Right Congruence? So I'll be giving you an example. The direction here is give the congruence required to prove that triangle hot is congruent to triangle sun. Remember, the congruence that you are going to write depends upon the given congruent parts. For example, we have here number 1. HO HO is congruent to SU. OT is congruent to UN. Both HO, SU, OT, and UN are the legs. So they are congruent by leg-leg congruence. Okay? Number 2. HT is congruent to SN. HT and SN are the hypotenuse. OT and UN or angle T is congruent to angle N. So, the two triangles are congruent by hypotenuse angle. Hypotenuse angle. Number 3, HO again is congruent to SU. Angle S is congruent to angle H is congruent to angle S. HO and SU are the legs. Angle H and angle S are angles. Therefore, triangle hat is congruent to triangle sun by LA congruence, leg angle. And for the last example, HT is the hypotenuse congruent to hypotenuse SN. OT is a leg congruent to UN, which is another leg. So therefore, triangle sun and is congruent to triangle hat by HL or high L congruence. So you are going to write the kind of congruence theorem that describes the congruent parts here. Okay? For our last activity, prove me right. The direction is to prove by filling the blanks with the correct statement and reasons. So I am going to give you the example again. So we have here the given angle WIN and DIY are right angles. This one are right. Another given, I is the midpoint of WD and YN. We are going to prove if triangle WIN is congruent to triangle DIY. So as I have said earlier, in writing the statement, the first statement that you're going to use is what is found on the given. So what is found on the first given? So we have angle WIN and angle DIY are right angles. The reason it is found on the given. Now, for the second statement, do not write the second given at once. What is your conclusion about this? What if angle WIN and angle DIY are right? So you are going to write, therefore, angle WIN is congruent to angle DIY. Why? Because of the definition of right angles. All right angles are congruent. Now, it's time for you now to write the second given. So that is what you are going to write on statement number 3. I is the midpoint of WD and YN given. So from this statement, what happens to WD if I is the midpoint? Okay, so your conclusion would be WI is congruent to DI. Why? Because of the definition of midpoint. Okay, the word there is midpoint. What about YN? What happens to YN if I is the midpoint? Therefore, YI is congruent to NY. Again, the reason is because of the definition of midpoint. The midpoint divides the segment into two equal parts. Now, we have already two given parts that are congruent, including the right angles. So, what part of the triangles are these? Okay, so therefore, triangle WIN is congruent to triangle DIY by LL congruence. So I hope you enjoy answering your activity 2. This Virtual instruction is not possible without the help of the math team. Sir Manny Ancheta, yours truly, Paula Bianca Cruz, Ofelia Mapata, Rowena Palaming, and Mary Grace Talbo. Keep calm and love math. Again, a pleasant day to each and everyone.